Hi everyone, this is Mr. Secoder here. Today I am going to discuss the problem Codeforces Round596 Division 2 Problem C, which is p-binary. Let's look at the question first. Vaishya will fancy any number as long as it is an integer power of 2. Petya, on the other hand, is very conservative, only likes a single integer p, which may be positive, negative, or 0. To combine these pairs, they invented p-binary numbers of the form 2 power x plus p, where x can be any non-negative integer. So let's look at what are these p-binary numbers. So for example, we consider p as minus 9. It can be negative, we can consider it sign. So the minus 9 binary numbers contain minus 8, which is formed by 2 power 0 minus 9, which is here x is a 0 and p is minus 9. 7 can also be formed with these two p binaries, that is with this minus 9 binaries. 2 power 4 minus 9 will result in 7. 1015 can also be formed, as you can see here. 2 power 10 minus 9 is 1015. Here we used only one binary numbers, but we can use some of these binary numbers to represent number. Let's look at another example. Here the p that we consider is 0. So we can represent the 0, 7 with 0 binaries as 2 power 0 plus 2 power 1 plus 2 power 2. Because since p is 0, 2 power 0 minus 0 will be 2 power 0 itself. Similar to other nation terms. Here we use it three such p binaries. So let's look at the constraints. N is in between 1 and n power 9. If you depend on n, if the complexity is big of n, it won't solve in 2 seconds. First case, it exceeds more than 2 seconds and your case won't pass. Your solution won't pass. So let's look at the p value here. It ranges between minus 1000 and 1000. So we have to concentrate on p more than n for approaching a better solution. So let's look at a solution first. How we have to approach this solution. So suppose you represent n some of p binary numbers. You want to minimize this k. So let's look at this. So if you are representing as sum of k binary numbers, we can form this equation like is equal to k such 2 for x of I plus p, where I ranges from 1 to k. Moving all the p's the right hand side to the left hand side, we can achieve this equation. N minus k into p is equal to sum of 2 power of k's. So as you can see, as you can observe clearly, the right hand side, the minimum possible right hand side is k. Why? The minimum possible right hand side can be achieved by considering all x of i's as zeros. That is k to, if we have we have k such term. By taking all those minimum, we get k into power of 2 power 0 is k. So in order to represent n as sum of k binary numbers, the n minus k into p should be greater than or equal to k. So let's consider the binary representation of n minus k into p. If n minus k into p contains more than k set pairs, we can't split it into k power of 2. Why? Because if we consider the binary representation of minus k into p, it contains more than k set pairs. It's nothing but binary representation. If you are considering the set pair there, you are actually summing with 2 power the bit position you are having. So you are already summing with more than k such 2 powers. So we can't combine them in order to form a smaller one. Like if we have less than k set bits, we can split larger powers to smaller ones in order to achieve that. It is nothing but we can always split larger powers to two small ones, right? So the number of set bits that you're having this particular valve should be less than k. This is the another condition that should satisfy or to achieve this n minus k into p is equal to sum of two powers of x. So in order to satisfy that condition, we need to satisfy these two conditions first. So now we can't iterate over all the values of k. Why? Because there's a required number of values starting from 0. We derive that n minus k into p should be greater than or equal to k. So if we take k common and by putting one of k into p term to the right hand side, and which is greater than k into p plus 1. So by p plus 1 is greater than or equal to k. So we in the constraints we know that p is in between minus 1000 and plus 1000. But here to satisfy this condition, uh, we need k is always positive. So p plus 1 can't be negative. The upper limit of k will be nothing but the upper limit of n. How can we achieve the upper limit of n? We have given upper limit of n as 10 power 9. So 10 power 9 can be represented as 2 powers as 2 power 30. So we can max have 30 bits. But we can take k max, that is the number of bits that your number of bits in a binary representation is nothing but sum of number of summation terms that you're using. Here is the term is to power something. So we can have maximum 31 terms here. So let's look at the implementation. We are reading n and k, the k maximum value of k is 2, so we find that. So we iterate over all k's possible and checking whether n minus k into p is satisfying the condition that we achieved before. We can see this here. One of the condition is this n minus k into p, if we are taking into that, should be greater than or equal to k, and the number of set bits in n minus k into p should be less than or equal to k. If these conditions are met, we are having that solution. You may have doubt like why we can always split larger powers to smaller ones. Let's look at an example so you'll have a better idea. So let's say you're having a value having a two set bit. Let's say we take 3 is having a two set bit. So what you're doing here is you're summing with 2 power of 2 comma 1 plus 2 power 1 plus 2 power 0 gives you 3. So here you're using only 2 terms, but I want 3 terms. How can this be possible? Because this larger power can fit into 2 large smaller powers. Is you can split the same 3 can be formed as a power of 2 comma 0 plus power of 2 comma 0 plus power of 2 comma 0, because this larger power of 2 comma 1 is split into 2 power of 2 comma 0 plus 2 comma 0, because in final representation it's nothing but higher power is a multiple of 2 into lower power, right? I think it's clear for you why the larger powers can be split into smaller powers in order to distribution. Okay, here. Let's look at how the test case is working. So I'm pasting this into .txt. And by the way, I'm using the Win editor. This is a super awesome editor. You can give it a try. It's worthwhile. And I'm working on even 2. So let's try this. Got the correct solution. Here already compiled. We got a correct solution. Stay tuned. Thank you.